Good afternoon, YouTube. Today's demo is going to talk more about external DNS. So I'm actually focusing a little bit, probably over the next couple of weeks, in digging down a little deeper into external DNS and how we can provide wide IPs, or if you want to call that, fully qualified domain name availability for Kubernetes pods, right? This is really cool if you want to do multi-site, multi-cluster. It could even be, like some type of active solution, etc. And so the cool thing about external DNS, it really allows this user, or really allows you to control your DNS records via Kubernetes CRDs. And so you would create these external DNS entries within Kubernetes. It's a little bit different than the external DNS project within Kubernetes. This is really utilizing F5 technology that is available today, specifically Big IP DNS. And there are going to be some additional videos that I'm going to start getting into that potentially would leverage maybe some of the community stuff. But right now we're leveraging the external DNS functionality, specifically front-end in NGINX Ingress Controller with F5 CIS, F5 Big IP, both LTM and both DNS, and then of course some IPAM as well. And so this is the architecture that I'm going to go and get into and talk a little bit about. So let's take a look at this architecture. Now, first thing first, this is a single cluster, and the only reason why I've done this is just for simple demonstration purposes. I have let's call it a data center or a site or a cluster called east.f5demo.com or east.example.com. It could be anything. This is not stopping you from creating an east and a west, right? I have created a video, it is in part of my videos, that does talk about multi-site external DNS. But I want to get into some other things here than specifically talking about, having multiple sites. And so in this instance here, yes, it is one site. And yes, Big IP LTM and Big IP DNS are running on the same Big IP instance. It doesn't have to be. CIS can communicate to a Big IP device running LTM and a Big IP device running GTM, right? As two separate devices, that's fine. You can do that. Today, this shipping supported architecture, it's fully supported, by the way, this architecture, as long as you're using NGINX Plus. This architecture and everything that you see here, this solution does require both Big IP LTM and Big IP DNS. Currently, like I said, I am going to start to explore where potentially CIS just communicates with the DNS piece. So maybe if you don't have a Big IP in the picture, then you can potentially use that. Maybe you have some type of API gateway. Maybe you have a NGINX reverse proxy, or you have some type of other service. It could be some type of Kubernetes cloud native service, right? And so that's coming. It's a little bit of work. Requires development, of course, but I am starting to write the requirements documents for that, right? So if you have ideas, if you want to share your information, please contact me. I'd love to be able to capture that, share my ideas with you and kind of what I'm thinking. So let's take a look at this. This is quite a big architecture, right? So we have CIS, and CIS is monitoring, of course, the CRD. The CRD purpose here is to put a public IP address on the Big IP and then load balance all traffic to NGINX, right? So you'll have one virtual server that will load balance to all of your NGINX Ingress controllers. And that's pretty easy. It's really just CIS. It's just really one virtual server, right? Potentially per application in this case, right? And then we're going to have some external DNS CRDs for CIS to create the wide IP. So CIS is going to create the, if you want to call it the L4 or the load balance connection into the cluster. And CIS is also going to create the wide IP on DNS to provide site availability, geographic availability, right? And so that wide IP will have a local pool. That local pool will be the public IP, right? The virtual IP address on big IP. What's cool here, and this is not optional, is CIS is actually using IPAM. So we're using the F5 IPAM controller, right, which is also developed by the CIS team, to actually pull and provide an IP address for that virtual server, right? So you don't have to do this. If you want to specify the virtual address inside the CRD, you can do that. But so what happens is when you create the CRD, IPAM will actually provide that IP address and provide and give that to CIS. CIS will configure that, right? And we can show you that in a second. What is also happening is the DevOps administrator or the DevOps person or the user that is creating their application pods. In this case, I have an application pod called Coffee, an application pod called Tea. That user is creating their ingress resources, and those ingress resources are simply just routed and managed by NGINX Ingress Controller. So CIS doesn't really know much about this because CIS is not load balancing traffic to your Coffee service and your Tea service. Big IP is really just load balancing traffic to the NGINX Ingress Controller, and CIS is really just creating that plumbing. So think of this as big IP to NGINX kick to the pod, right? What is important here is that when we create a wide IP for cafe.example.com, DNS doesn't know anything about a service, specifically a service and its availability of the service. So DNS doesn't know whether the service is up or down unless we can monitor it, right? And the other thing that DNS is not aware of any L7 path information, right? So what we can do is inside our eDNS CRD, we can actually create a DNS monitor that will monitor the path. And so why that's important is that because this monitor, let's call it this DNS monitor, you can see it here, it's connecting to its big IP DNS is connecting to NGINX, and then NGINX is forwarding it to the Coffee service or to the Tea service. So if these services go away, if these endpoints are not reachable, and therefore there's no response for get/coffee or get/tea, what will happen is we will remove and not provide this A record, right? And so if you're doing a multi-site, think of it, multi-site can have one wide IP, but it can have multiple, what we call pool members, right? And the pool members are really just where we're going to load balance to. And if the backend fails, we can actually pull that pool member down. So if site A fails, we can pull that pool member, but we can still serve site B, for example. And so that's what the whole concept here is if you do multi-site. But what's really cool is that when I configure this DNS service for cafe.example.com and I monitor these services, if these services go down, we will take the wide IP down and we will not serve that A record, right? And so that's actually kind of cool. And that's all configured through DNS. So let's take a look first at the CRD. The CRD here, the CRD that is configured with CIS. And so I'm gonna just scroll down here. You can see if you just follow my documents, it talks a little bit about how to configure CIS. You can see that CIS here is using IPAM, and you can see that CIS is connecting to both big IP as well as GTM, and also CIS is watching the following namespace called NGINX Ingress. Right? So it's only watching that namespace because that's what NGINX is listening on. Very simple how to create. I've really simplified this. You only need these three files. This is for the CNI, but you only need this for the deployment. And I've put all of your cluster role bindings in one YAML file. So it's real simple. To create the IPAM, I have created a test. Think of this as a label, and we use the label to specify in the CRD. And what will happen is when we use that label, it will pull an IP of this range. We have got some persistent volumes so that we can maintain the persistence of the host name to the IP for IPAM. So IPAM is really simple to set up. Follow these. This is the latest 2.7. Follow these, pull these down from my repo, and you'll have no problem. If you need troubleshooting, select the link. Configuring NGINX controller. It's pretty simple. Just follow these steps. I'm also using OSS here. I'm using the open source. Please make sure that you use NGINX Plus. Let's take a look. And then here's how to deploy the Cafe app. So this is kind of how you would deploy the Cafe app behind the NGINX Ingress Controller. Great. So now that we have all of that done, let's take a look at the coffee and tea service for that CRD. So as you can see, you can create these locally, and these are the local services. So let's go and actually take a look at that. Let's go to my repo and pull where these things are located. They're all in the diagrams in this quick start guide here that I provided. You can see the examples are here. So let's go into Cafe. And so here is the CRD. And so you'll notice within this virtual server, it's a virtual server CRD, right? So that's the first thing that you create. And I specify in a namespace. But most important is, of course, my host name is cafe.example.com. That's what NGINX is expecting. Here's what's something quite interesting. What this host group is doing, this host group of Cafe, it's a namespace. It could be anything. Just call it Cafe. But all the virtual servers that have this host group Cafe will have the same public IP. So that's really cool. So think of it as like OpenShift routes. This is doing host-based routing. So whatever IP address is associated from IPAM is going to have that same IP. So if we go look at Big IP, and if we look at what Big IP has to show here, we'll take a look at our LTM configuration, right? Because this is what's going to happen when you configure it. We're going to change the tenant. So you'll notice that I only have one public IP for 443. And if I go down to my resources, this is what's really important. When I go down to my resources, you're going to see here, I have a host for cafe.example.com/coffee and a host for cafe.example.com/tea. Right? So these are the two CRDs that I've already created. And so here we go again. So you can kind of see I am doing re-encrypt. So I'm terminating it, taking a look at the specific URI. I'm on port 443. Here's the host group that says everything will have the same public IP as long as it's within this, as long as I specify the host group. Here's the IPAM and here's the backend monitor. Right? This is for coffee. Let's take a look at tea and we can talk about some of the commonalities there. And so here's tea. So as you can see again, it's host group of Cafe, it's test as well, and this is monitoring. So this is local monitoring on your LTM. And so you'll notice that there's two CRDs here. Let's go take a look what these two CRDs look like in Kubernetes. You can actually see it here. I'm gonna make this a little bit bigger. So you can actually see here that here is the one CRD for VS. This is for Cafe. It's re-encrypt, right? This is the one that was created in there. This is the second one that was created. You'll notice this is the IP address that was pulled from IPAM, right? I've created quite a few videos on IPAM, so if you want IPAM help, just let me know, or just view one of my videos. But they both have the same IPAM label, and they both have the same host name, and they both have the same IP address. And so that's if I look up the virtual server CRD. So at this point, what we've done is we've configured the LTM piece. So there is the LTM piece. That LTM has a pool member. You'll notice that this is NGINX. And so here's my member. There's just one. That is the NGINX Ingress Controller. So if we go back to the diagram, you can see in this diagram the LTM piece. I have 3 here. I just only have 1 replica, but it's no problem. You could have 3 replicas if you have 3, and there you'll see 3 pool members. These are configured, so I can actually hit this if I point my DNS server to cafe.example.com, but point it directly to that IP address, right? Because obviously I need to resolve the DNS, and it needs to resolve locally, right? And so then I could kind of get access. But what I want to do next, the most important, is I want to create the wide IP, right? So if I go take a look at DNS here, right now I have no wide IPs, right? There's no wide IPs and there's no monitors. So what I'm going to do in Kubernetes is I'm going to go create these. Let's create eDNST first. So prior to this demo, I deleted it. So let's go and create it. So very simple kubectl command here just to create this eDNST service. So as you can see, I've created this T service, this T eDNS. So if we go and look at what that looks like, let's see what I just created. I just created eDNST, and you'll notice here that there is my domain name. So my domain name's the same. Now this is kind of really important. Here I have one domain name for many applications, right? So cafe.example.com/t/coffee/latte/macchiato/ anything you want, right? So the thing is that because I have multiple services, multiple backends, I need to monitor those services, right? But I only have one domain name. So the thing is that what happens if I fail? What happens if coffee fails? Do I fail the entire domain name, or do I not? Do I keep on servicing that domain name out, right? So this is the choice about what you need to do. What's preferable is for your pods to have some type of health monitoring status page, right? So if you have, let's say you have, in this case, 2 pods. In my case here, in my diagram, I have coffee pod and tea pod. What would be kind of cool is to create a monitoring pod here, so that I only have to monitor one. And if either one of the endpoints goes down, or some type of API goes down, then I can just remove the wide IP. But in this case, I am monitoring both, right? And so I want to get your feedback, right? I want to get your feedback here because there's a change that I need to make in CIS, potentially CIS 2.8. What is the right behavior? Is the right behavior if we fail coffee as well as failing tea, we take it out? Or is it if we fail one, we take them out, right? And so this is the kind of feedback that kind of I'm looking for. Right now, the monitor piece is kind of overriding itself. It's a bug that's filed with development, but I'm looking for feedback on how we should implement that. And the feedback I need the feedback from the community. Most likely what I'll do is, if we don't get feedback, what we'll do is we'll add multiple monitors to the wide IP, and if one of the monitor fails, we'll remove the wide IP. But we'll provide that as configurable. So I created the wide IP. I created the eDNS CRD for the wide IP, specifically for T, only for T. So the monitor should only be going to T, so only T service should be there. So let's take a look. So as you can see, it's up. Cafe.example.com, there's a pool there, and this is the virtual server pool. I should only have 1 member. It's showing 2 members because of the redirect. This is already fixed. If we take a look at the monitor, you can see here's the monitor, and there's the monitor for T. We're also doing the CNI. So we're creating the CNI server name right there as well. So there's the monitor for T. There's the monitor for CNI. If I go there now and auto refreshes, I should be able to get an IP address. And as you can see, monitor is working. What happens if I go back to my diagram? You can see monitors just refreshing there. So let's go back to my diagram. What happens if I go and I replica all of these pods down to 0? we should no longer serve that A record. So let's check that. Let's try that. There's a scale command here. Let's see, it should be, here we go. So let's scale this down to 0. So what I've done is I've scaled the tpods down to 0. So what will happen is when you scale these down to 0, this monitor string is going to fail. So therefore, DNS should automatically remove the wide IP. The wide IP should basically be in a failed state. And as you can see right there, the wide IP is in a failed state. If we go look at the monitor is going to show, actually we can go look at the pool, and the pool will come back and say, the member, this is the member I want. The redirect has been removed. And as you can see there, that there's a server error because the monitor is not up. And so, for example, here, when you refresh DNS, it will not serve it, right? You're basically not going to serve it. I'd have to close my browser, reopen my browser, but if you refresh, because it's cached, right? So if you remove the cache, at this point, it won't get served. There's this, but basically that's kind of how that's working. So if I scale that up to, let's say, 4 tpods, this thing will come back online pretty quickly. You can see the wide IP. Give that a minute, it'll be back online within no time. See, it's back on green again, and you'll be able to resolve that. No problem. You can continue doing that. So you can do the same thing for your other CRDs. So here we saw this was T. This is T right here. And if I create another one, which I can do for coffee, it's very similar, right? It's very similar right here. This is I need to create the eDNS for coffee. This is the eDNS for coffee that is created. It's the same domain name, right? So it's one domain name because I'm front-ending Kik, and that's fine. I'm front-ending Kik specifically for these applications. It depends on your applications. If you have a one-to-one mapping, this works amazing. It's so easy, right? Because it could be like Cafe 1, and your wide IP is Cafe 1, and your backend service, you only have one monitor because you're only monitoring Cafe 1. But when you have one domain name and you're monitoring lots of items, you have to really require these different send strings, right? So there's kind of what that looks like in this example right here. So to highlight kind of what we did, we have site east or data center east. In data center east, we have a big IP that has both LTM as well as DNS. And this big IP is front-ending a Kubernetes cluster with Kik NGINX, with NGINX Ingress Controller that is load balancing to all of your Kubernetes services. What CIS is doing is CIS is creating a local CRD to configure the big IP to ingress traffic to Kik for all of your domain names, in this case, cafe.example.com, and then it will have the path /coffee.t. And then what CIS is also doing is CIS is creating the wide IP for cafe.example.com, and CIS is configuring your DNS for site availability, and your local pool member will be the LTM piece, which will be communicating with NGINX Ingress Controller. So that is the demo. Everything is here. I'd love to get your feedback. Please like and subscribe. There are lots of videos coming. And if you want to see something specific, please let me know. Thank you.